Hello, geometry. Here we are again with another section. We got 11.5, exploring solids. Do you feel adventurous? Okay, we're going to start our study of three-dimensional figures here, or solid figures. Okay, let's start out with names and parts. The general one here is going to be polyhedron. Is just going to be any solid that is bound by polygons. It's made up of other shapes on the sides. Any solid that's bound by polygons. The plural of polyhedron is polyhedrons or polyhedra. Okay, each face would be the polygons on each side. So the faces are going to be the individual sides of the polygon. The edge is the line segment formed by the two intersecting faces. Where two faces meet, okay, those borders are called the edges. And a vertex is a point where three or more edges meet, aka it's the corner. Okay, so if we're looking at this, like the top would be a face, the front trapezoid is a face, okay, the left and right rectangles or squares would be a face, the bottom rectangle is a face. Each of those is going to be a face. It's a side. Okay. The lines here that you would draw, those are the edges. Okay, and where all the corners are, those are the vertices. Each individual one would be a vertex. Types of solids. Okay, we have polyhedra. Things that are bound by polygons, things that are not. Notice the round ones are not polyhedra because they're not bound by different polygons. They're not made up of polygons on each side. Okay, polygons are multiple-sided figures. Technically, these round ones don't have any sides. Okay, but over here with the prism, the rectangular solid, a prism, or the pyramid, okay, those are going to have a bunch of sides, clearly defined sides. We don't have any rounded edges. Okay, so those are going to be polyhedra. When naming prisms or pyramids, we use the shape of the base. We use the shape of the base. What's the base? Okay, when you have a prism, it's the one that has the matching shape top and bottom, or sometimes it's front and back. Okay, if you're looking at a prism, we have a pentagon on the top, pentagon on the bottom, and then we have all these rectangles connecting the two bases. Okay, so it's pretty easy to tell. If it was a prism, something like this, okay, it's going to be a rectangular prism. It's all rectangles. But when it's something different than a rectangle, it's pretty easy to spot because it's the different shape. Okay? And if it's a pyramid, it's going to be the bottom of the pyramid. Okay? So this is actually the tough one. Because it's tough because they're all triangles, but that makes it easy, I guess, because you could say it's a triangular pyramid, and you can't be wrong because they're all the sides are triangles. Okay, otherwise it would be the shape that's different, that's not a triangle, that's on the bottom. All right, so that's classifying solids. You name them by the base, and then you put prism if they go straight up to another matching base, or a pyramid if they go up to a point. Okay, guys, time for you to try it out. State whether the figure is a polyhedron. If it is, name it. Okay. Then state the number of faces, vertices, and edges. Okay, what do we have here? Think about it. I got a triangle in the front, a triangle in the back, and rectangles connecting them. This is going to be a triangular prism. Triangular prism, number of faces, it's got a front and a back. Okay, you get the left side, right side, and then the bottom rectangle. So there's two triangles, and there should be three rectangles. So that's going to be 5 faces. Okay, and then the number of vertices. Get the 3 on the front triangle and the 3 on the back triangle. So 6 total vertices. I missed edges. edges. 3 on the front triangle, 3 on the back triangle, and then the 3 edges that connect the front to the back. So there's actually 9 edges. Our middle one here is a sphere. It's rounded, not a polyhedron, because it's round. Okie dokes. And our next one here is going to be a rectangular prism. We got a rectangle and a rectangle there. And we're going to have 1, 2, 3, 4. 4 rectangles on the sides and a top and a bottom. So we're going to have 6 faces. Vertices are corners. 4 on the front, 4 on the back. That's going to be 8 corners, 8 vertices. And edges. 4 on the front, 4 on the back, and 4 connecting the front to the back. That's going to be 12 edges. Okay. So you should start to see a pattern here with the number of faces, vertices, and edges. That's Euler's theorem. It's foreign, French or something. It's not Euler. Euler's theorem. Okay. The number of faces F, vertices V, and edges E of a polyhedron are related by the following formula. Faces plus vertices will equal edges plus 2. Faces plus vertices will equal edges plus 2. Does that work up here? Faces plus vertices, 5 plus 6 is 11, would equal edges plus 2. 9 plus 2, 11. Faces plus vertices, 6 plus 8 is 14, will equal edges plus 2. 12 plus 2, 14. Okay? That's a pretty big one. Let's write that down. F plus V equals E plus 2. All right, you're going to be using that one on a significant portion there of your homework today. Let's try it out. Find the number of faces and vertices and edges. Check with Euler's theorem. Okay. Faces. 1, 2, 3, 4 around the sides, and in front and the back makes 6. Alright, vertices, 4 on the front, 4 on the back, that's 8. Edges, 1, 2, 3, 4 connectors, 4 on the front, 4 on the back, 12 edges or like sides, like lines. Okay, F plus V is 14, that should equal E plus 2, 14, you bet. You're going to have some problems on your homework like this, where they give you faces, edges, vertices, and they're going to give a variable in one of them. So you just got to set that up. F plus V equals E plus 2. Alright, we're going to put those in. N plus vertices, 8, equals edges, 12 plus 2. So we're just going to use some algebra here. N plus 8 equals 14. What do you have to add to 8 to get to 14? It's going to be 6. Okay? So that's some types of problems you might have on your homework. Cross sections. A cross section is the intersection of a plane, a flat two-dimensional surface, and a solid. Okay? Imagine a plane, 2D, piece of paper, thin piece of paper, slicing through a solid three-dimensional figure shown below. That two-dimensional slice of your solid figure is called a cross section. The diagram shows a cross section of a triangular pyramid, and that cross section through there is going to be a triangle. Okay, that little slice, that little slice right there is going to be a triangle. Okay, let's take a look at some other shapes. Now, depending on which way you go, it could change the shape. Okay, we have 3 identical pentagonal prisms, pentagons in the front and back, rectangles connecting them. Okay, we're going to slice it 3 different ways. We're going to get 3 different cross sections. If I go this way, you can see we're going to have a rectangular cross section. If I kind of slice it at an angle coming this way, I could get a trapezoid. And if I slice it this way, I'm going to get a triangle off the corner. So it just depends on the angle of the slice. and which way you're going into that shape, you could end up getting different shapes. It doesn't necessarily always going to be like you would think, oh, pentagonal prism. I'll slice it front to back like that, and you're going to get a bunch of pentagons. Well, what if you just go like this, the flat way? You're going to get rectangles. Or if you come at this angle, you're going to get trapezoids. If you go at that angle, at a corner, you could get triangles. Okay? So it just depends. All right? This one's a little bit more mellow of a lesson. It's not as strenuous as 11.3. Not even as much as 11.4. So you guys should be fine. Big formula to remember, F plus V equals E plus 2. Okay? And naming things. Alright, when we're classifying. Okay, we name it by the base, what shape the base is, and if it goes up to another one of those, it's a prism. Pentagon on the bottom, pentagon on top, pentagonal prism. Okay, if it would have been a pentagon on the bottom going up to a point, okay, that would have been a pentagonal pyramid. Remember that polyhedrons have polygons for sides, okay? If they got a cylinder, cone, sphere, the rounded ones, not going to be polyhedrons. Okay? Here's your homework. We have page 746 for the weekend, 3 through 20, 25 through 27, 34 through 38. Okay? Probably pretty nice weather this weekend. Make sure we get our homework done because we got a big week next week. Okay? Tuesday, coming back with a practice quiz. Wednesday's a quiz. Thursday, we're going to get that quiz back, go over it, and check the practice test. Friday is the test. Okay? Big week next week. So let's make sure we get all our homework taken care of this weekend. All right, guys, we'll see you on Tuesday.